hosting us and providing logistics and support for the event. It is the first time that we are hosting these events virtually, given the current public health situation and the impossibility to meet physically at this time. So we have adapted our program to this virtual format. We'll have these sessions over 2 weeks to accommodate participants from across the globe. As a result, we will have shorter presentations to match all the different time zones that are represented during the training. All sessions will be streamed live through Zoom. And in addition, sessions will be recorded and will be available for future use. This will allow those of you who cannot stay the whole time, or those of you connecting from different time zones, to rewatch or watch the event at a convenient time. Finally, training materials and recorded sessions will be made available on the conference website. After the training, you will receive a short survey seeking your feedback on the training, and we hope you will take a few minutes to complete the survey, as your input will be important for us to continue improving the effectiveness of the training. So this week, you will have the opportunity to learn more about Sdmx with 7 training sessions spread over the course of 4 half days. Today, we start with a basic introduction of the Sdmx standard and how to build a data structure definition. Tomorrow, we will give you an overview of different tools available in Sdmx, including a demo of the Sdmx converter. The last 2 days will offer training on more advanced topics. On Wednesday, we will show you best practices for modeling data using the Sdmx information model and how Sdmx web services can be used to retrieve data from public Sdmx sources. And finally, on Thursday, we will provide an overview of the different approaches and IT components to be considered when implementing Sdmx architecture in your organization. For the first time, we're very happy to offer Sdmx training in 2 languages, English and Spanish. Participants will have the opportunity to always choose their preferred breakout room, following the instructions provided by INEGI in the training agenda. The same training materials and topics will be discussed in the 2 tracks. We hope that by offering the course in Spanish, we will improve the experience of participants from Spanish
elements of Sdmx. We have the technical standards, or the core of Sdmx. This is basically what is described by the Sdmx specifications, which are published at the sdmx.org website. The specifications, the technical standards, describe how statistical data can be presented, what are the formats of data transmissions, how the Sdmx registry works, what the sender and the receiver need to do to exchange the data, and so on. All of this is embedded in the technical specifications of Sdmx, which are published at sdmx.org. But by itself, this is not enough. This is not sufficient, because even if we know how to structure and present our data, we also need to agree on the common concepts and codes, if nothing else. Remember, Sdmx allows you to create concepts, such as sex, for example. But if you want to exchange your data, we want to know what the code for male is, what the code for female is, what the code for total is. We need an additional layer of statistical standards, statistical guidelines, in order to be able to effectively exchange the information. And this is what the second crucial part of Sdmx, which is the statistical guidelines. And the statistical guidelines include the recommendations for the management of Sdmx artifacts, lists of common concepts, methodologies, classifications or code lists, recommendations on the modeling of statistical data. These are also published at sdmx.org under the section on guidelines. And finally, aside from these two components, we need the actual software, the actual tools and architectures to enable us to exchange and disseminate our data. Tools that help us design our data exchange, that help us map data between the different systems, that help us package the data, exchange and disseminate the data. So these are the main components of data Sdmx standard. I would rather say not even the standard, but the Sdmx world. When we exchange data or metadata, generally we have two modes. The traditional and most widespread mode is push mode, the so-called push mode. What happens here is that the receiver sends a request to the sender, sends a request for data, for example, by email, which is the most typical these days. And the sender prepares a response with the data and sends it back to the receiver. The advantage of this approach, the advantage of the push mode, is that it doesn't require a lot of infrastructure. You don't need to have sophisticated systems. And as we will see, I think tomorrow, you can have some really, really basic tools, such as a laptop, a Microsoft Office, and a simple tool such as Sdmx Converter from Eurostat that enables us to structure the data in accordance with the Sdmx standard and the Sdmx structure. And then once the data is packaged this way, it can be sent by email. So this is great, but this is not the most efficient way, because, I mean, even on the technical side, sending large data sets by email is problematic. Plus, there's always a time lag between the request and the response. And finally, the exchange can only take place at certain times upon request. By contrast, there's also the pool mode of data exchange. With the pool mode, the sender makes their information available for anyone to use, available in some kind of a permanent storage database with an accompanying web service. In this case, the receiver does not send a request directly to the sender. Instead, it simply queries the online storage which is available. And the receiver can query that web service at any time. And this approach makes the data available for use as and when required. And Sdmx has a very rich support for pull mode, including notifications that the sender can automatically issue that inform the receivers, those who are interested in their data, that the data set has been updated. Using this approach, you can fully automate the data exchange process. The sender publishes the information. Receivers are informed about this. Receivers send the request and receive the data and put their in their database. All of this can happen entirely automatically without any manual intervention. This has been tried and tested and be shown to work very successfully. Now, you don't need Sdmx to implement these two approaches. In principle, push mode and pull mode, they're not specific to Sdmx. However, if you try to do this, then you would still need some kind of a standard to agree between the parties so that they are correctly, so that they can correctly understand each other. Or the sender develops their own standard and sort of imposes it on the receivers. Here's my information, this is how you must use it. And then whichever way it takes place, it's simply a lot more expensive, a lot more costly to implement data exchange without a standard such as Sdmx. It takes a lot more effort on the part of the receivers to understand the sender's data. So by implementing standardized data exchange and metadata exchange. You save a lot of money, you improve the efficiency, you greatly reduce the effort that is required by the implementation of data and metadata exchange. Now, on this next slide, it shows a possible architecture for Sdmx data exchange, and you can see how many components are here. It may sound intimidating, but in reality, it's actually quite straightforward and has been shown to make, and again, it has been shown to work pretty well. So in this possible architecture for data exchange, what you have is in the bottom left corner, you have dissemination information systems where the source original data is published. Here and here, it's not Sdmx yet. Through mapping software, the source data is mapped to Sdmx data structures and is made available through information exchange services, typically a web service. This web service can communicate with the registry, Sdmx registry, which is also part of the standard, to send a message to the registry that my dataset has been updated when it has been updated. The registry can send notifications to consumers of the data, to the receivers, to inform them that a dataset has been updated. And once the consumers receive those notifications, they can request the data from the web service and receive the data back. And once the data is with the consumer, it can be transformed into a variety of formats. It can be stored locally. It can be further processed and analyzed, or it may not even have to be stored. The consumer, instead of storing the information locally, may simply request the data from the original web service whenever it is needed. For example, data that is used to produce a chart or a graph on a page. This is the most efficient mode of data dissemination and exchange, and it implements the so-called federated architecture, where the information is requested from the source whenever required. And again, this approach has been tested and found to work very well in Sdmx. Sdmx data messages, they have a defined structure. They have a header, which describes some basic process metadata, basic information related to the message. It has the payload, the data itself, the observations, and sometimes when necessary, a footer is also used with information, further information on errors and others. This is actually important because every Sdmx message has a header. And when you are creating an Sdmx message, you must put some basic information into the header, such as, for example, who the message is coming from, the sender information. Now, this slide is very, very important. And this is something which, when you are working with Sdmx, you will deal on a daily basis. The issue is that your source data is not in Sdmx. Your source data, which comes from production systems, can be, or typically is, in a variety of different formats. It could be CSV, it could be text files, it could be survey files, it could be some pre-aggregated Excel files, a variety of formats. In order to transmit Sdmx information, this source information needs to be mapped to an Sdmx data or metadata structure. This is a very important point because your source data, whether it's database or CSV or Excel file, has a certain logic. Whether or not they are explicitly declared, you still have concepts and codes and other information in your source data. And what you have in an Sdmx structure typically it will be different from what you have in the source data. The data or metadata structure will have different concepts, different codes, different ways of organizing the data. And in order to be able to transmit the information, you need to map your source data to the Sdmx structure. And this is the point. When you are exchanging information, you spend most of the time, well, not most of the time, but most of the effort goes into mapping your data to the data structure definition. Mapping is what takes the most effort. Technical issues, most of them have been solved, but mapping, looking at your own data with its own logic, and then looking at the Sdmx structure with a different logic and how to map these them between themselves, this is where most of the effort goes when you work with Sdmx. And if you are using Sdmx for dissemination, then you also spend some time designing the structures in the first place. This is actually an important point. When you use Sdmx for exchange, when you want to report your data using Sdmx, then someone will give you a data structure definition with its own logic. And then you map your data, the source data, to the data structure definition that was given to you. Whereas if you are using Sdmx for dissemination, then you design your own structures and you map your source data to your own structures. In this case, you are responsible for your own structures. They're not given to you by someone. And then you obviously need to spend time and effort designing the structures. The great thing about this is that there are a variety of software that automates this process. It used to be very difficult to map your data and for exchange or dissemination. You had to develop applications that do that. But in the last 10 years, very powerful software tools have been developed that enable you to map the data automatically, and moreover, to map the data in a variety of scenarios, from very basic or even non-existent infrastructure to very sophisticated infrastructure. Software tools such as Sdmx Converter and Sdmx Reference Infrastructure developed by Eurostat, Fusion Registry developed by Metadata Technology, they can be very useful and they can really, really reduce the effort on data exchange and dissemination. This is, again, something to remember. Data exchange and dissemination is complex. And Sdmx reduces this complexity. And it does it by offering standards and tools in support of those standards that allows us to spend less time and achieve more in less time with less effort. Sdmx data flows. What is a data flow? Actually, we'll be talking about that in the data modeling presentation, but Sdmx data flow can be thought of as a transmission or dissemination channel. You have data flows everywhere. If you receive a request from UNSD or from the World Bank or from UNICEF or from anyone else with a questionnaire, and you complete that questionnaire and send it back by email, this is your data flow. So what Sdmx attempts to do is, and what it does, is to automate those data flows, to automate these processes for data exchange and dissemination. So on the top, you have this traditional data flow from the sender, perhaps the National Statistical Office, to a receiver in, let's say, an international agency. And these data can be sent by CSV or by Excel. This is the traditional architecture. They can also be sent by with Sdmx, because again, Sdmx does support traditional push communication channels. At the bottom, though, you see a much more sophisticated architecture, where instead of two humans sending data to each other by email, you have two web services talking to each other and describing and exchanging information as necessary. What is important to note is that in many ways, this automated data exchange emulates the manual data exchange that takes place in the traditional communication. Just as you complete a questionnaire and you send it by email in a message, Sdmx also exchanges data and metadata using messages. You have an Sdmx message that contains a certain data set or metadata set, and this is the one that is exchanged between the sender and receiver. And in the case of Sdmx, the process, as I mentioned, can be fully automated. Sdmx is meant for machine-to-machine communication. Therefore, you have a machine producing the message on one side, whether it's simple software or such as Sdmx converter or a web service. The information is retrieved and packaged as an Sdmx message, which is then sent to the receiver. Data flows in Sdmx, you can establish multiple data flows for the same subject matter domain. Data flows can be categorized, data flows can be described, data flows can be used for both data exchange and dissemination, and data flows help you automate the data exchange and dissemination, help you discover the data available, and help you visualize data. And this is seen at the next slide. So once again, you have a source database, a data in or a CSV file or an Excel file, data in whatever the source format. The data is retrieved and packaged as an Sdmx message, which is then posted on a data flow. And you can see that there's a whole layer associated with the data flow. I mean, first and foremost, a data flow is always linked to a data structure definition. And when you post a data flow, when you post a message on a data flow, it is automatically checked for its structural integrity. It will be checked whether the message contains all the valid concepts, all the necessary concepts, all the dimensions. It will be checked whether the message has all the valid codes. And if your message has some incorrect information, missing concepts, for example, or invalid codes, it will be rejected. In Sdmx, validation is very strong. But sometimes structural validation is not enough because, for example, you can mistakenly provide a value for a concept that does not apply to the indicator. For example, you are posting data on the land surface area and you attach sex male to it. Now, as long as you have the correct indicator code for surface area, and as long as you have correct code for sex, then this message is valid from the data structure point of view. But obviously, it doesn't make sense in reality. And to ensure that this doesn't happen, we can use content constraints attached to the data flow. And these introduce a layer of logical validation on top of the structural validation that we already have. You also have categories that can be attached to the data flow. These are very useful in discovery of information. Again, we'll talk about that more in the data modeling presentation, but you can categorize the data flow. You can attach tags to it that explain what that data flow represents. You can attach categories that tag a data flow as macroeconomic statistics, for example. We can drill it down, macroeconomic statistics, national accounts, and so on, or demography, or social statistics, or anything else. And this helped the user discover that data flow and discover the data and consume the data. One of the final slides, Sdmx Global Registry, registry.sdmx.org. Please take note of this web address. The global registry was created to store globally agreed Sdmx artifacts, globally agreed concepts and code lists and data structure definitions. Successive versions of these artifacts are posted here, and the previous versions are always available. Here you will find data structures, global data structures for national accounts, for sustainable development goals, for consumer price index, and all the others that have been posted at the global registry. You can use the registry. The registry to be informed when these artifacts are updated, so that when if you subscribe to changes, then whenever an artifact that you're interested in, for example, a data structure in national accounts, whenever it is updated, you will receive a notification, and then you can take action. You can take action on that. Remember, we talked about the statistical guidelines that are part of the Sdmx standard. The statistical guidelines that are posted at the sdmx.org website, but the statistical standards, concepts, code lists, data structures, they are all posted at the global registry, where they can be downloaded and used as Sdmx messages. Oops, I think that I clicked on the link. 1 second. Okay. Can you still see my presentation?
Yes, I can.
Okay, yeah, thanks, David. I think I clicked on the link again, but let's see. Okay, fine. Sdmx.org. Also, please take note of this address of this website. This is where all the information related to Sdmx is published. This is where you will find information on this is where you will find the Sdmx technical specifications in the first place. This is where you will find announcements of public consultations. This is where statistical guidelines are published. This is where a list of Sdmx tools is maintained, which is again extremely important, because this is where you can look at the available Sdmx tools and find those tools that are suitable for your purposes. So, and this is also where information about Sdmx events is published. As you can see at this screenshot, you have an announcement of the global conference in which we're now participating at the top of the page. So please take note of this. And whenever you have a question related to Sdmx, I think the first point of call would be the sdmx.org website. There are other websites with addresses here where a variety of information about Sdmx can be found. I will not go through this detail, but these are the web services, these are the dissemination portals, these are the guidelines for data exchange, and all the others that can offer a wealth of additional information about Sdmx. So please use these web pages whenever you need them to obtain more information about Sdmx. And this is all. This is the end of the presentation. Thank you very much for your attention. And now we can take the questions. So, David.
Okay, so Abdullah, for now we have how many? We have 4 questions. Okay, so if I go to the first one, so the first question is, are there any data to show how efficiencies in terms of money saved or revenues generated now that Sdmx has been in use for over 10 years? So are there any data to show the efficiencies regarding money saved or revenues now that Sdmx has been around for 10 years, over 10 years? That's question 1. Do you want to answer that first, and then we go to the others?
Yeah, I mean, let's pause here. Actually, this is a very good question. I think that we're now working on that, the Sdmx Secretariat, but if we're talking about the hard data, off the top of my head, I don't recall such an analysis. David, Luca, would you contribute to this?
Just to say, I was looking around when this question was posed to see if I could find any case studies actually with hard data, and I couldn't find any. I mean, there's lots of presentations from various implementations to say, what they did and how they implemented it technically, but I couldn't find it in a quick search. Some hard data in terms of money. So.
If you allow me, Abdullah, just to complement.
Please go ahead, Luca.
I think we don't have an overall study, let's say, at the level of the sponsors on this. We do have, and we have seen several case studies of how Sdmx was applied in specific cases and again, the benefits it provided. Unfortunately, as David mentioned, I don't think we have a good library of these case studies. I remember the World Bank had worked a bit on this, on providing a set of case studies that could be consulted for newcomers to see what they could expect in terms of difficulties and also implementation benefits. But I think we can do a better job of giving more visibility to this information on the sdmx.org website.
Yep. Thanks, Luca and David. One comment I have is Sdmx activities are global, and to put a money figure on that is actually quite hard, because I mean, if we look at the, okay, I think that please mute yourselves if you're not speaking, because we have some background noise. Please mute yourselves if you're not speaking. Yes, if we look at the European Union, for example, where the countries are now reporting in Sdmx in national accounts and in other subject matter domains, the money saved is the time that people used to spend completing the questionnaires, and now they don't have to do that. So in the case of sustainable development goals, it's not so much about the money saved as about the possibility itself, because by using Sdmx, the countries gain the ability to report their SDG indicators to the in this case, the receiver is UNSD. Without that mechanism, they wouldn't even be able to report their data because UNSD does not have the resources to process the national data. So the answer is complex. Yes, we can be certain that Sdmx saved quite a bit of money to a variety of organizations, but putting a hard figure on that is not easy. But this is something that I think needs to be looked into in more detail.
Yeah, so there was the follow-up comment on this that it's important when we talk about it in our presentation. I think when we make these claims, that it saves money, etc., because we need to let development countries know about the money saved in order to incentivize them. And just for me, yeah, that data will be really great for us as well. So, and if we had it, we could actually, quote it in these presentations. But yeah, as Abdullah said, it's hard to come by. But Abdullah.
Yeah, it's hard to quantify, but it's something that definitely, should be looked into. Okay, I think we're done with this question.
Yeah. Okay. So the next one, we have 6 more. Well, the question is, could you also speak to the reverse, i.e. mapping back to the source format? And I think that this question came in when you were talking about the mapping,
Yes.
the mapping between systems.
Yes. Could you also speak to the reverse, that is mapping back to the source format? The answer is yes and no. If you're talking about, because look, this is what Sdmx tools allow you to do today. You can connect to practically any data source, any database. Well, there are certain supported databases like SQL Server, MySQL, and which one was it? Oracle. It's easier to connect to them, but in principle, with a little bit of tricks, you can connect to any database or Excel or CSV file. And then the mapping tools can transform the data from your source into an Sdmx data set compliant with the data structure definition. To go back from Sdmx to your original format would require that the mapping software understands your original format. And that, well, obviously is quite tricky. So to go from Sdmx back to your database with the same ease is not always easy. However, you have quite a number of approaches that can help you mitigate this issue. To begin with, you can go from Sdmx into a format like CSV, for example, that you can use to map and load data into your database. This is one. But what is increasingly used, what is increasingly practiced is that your database is Sdmx native in the first place. What you can do today, and what I think you will see on Thursday, is you can take a data structure definition and then automatically create a database based on the data structure definition. And then you can automatically load Sdmx data into it. This is increasingly practiced, this is increasingly common. And in this case, yes, because your database is Sdmx native, you can easily get the data out of it, but you can also put the data back into it. And this approach has, again, proven its merits and is increasingly used and is more and more widely supported by available tools. Luca, David, would you like to add anything?
Well, for me, it's fine. Luca?
Nothing from my side.
Okay. Shall we go to the next question, Abdullah, because we still have 6 more?
Yes, please go ahead.
Okay, so the next one is, do you think that pull mode provides specific information released by the sender and it does not cover all requirements of the receiver?
Well, I think that Sdmx was in large part created to answer these questions. When you use Sdmx, the sender and receiver agree on requirements. This is fundamental in multilateral data exchange. Therefore, yes, if you are using SDMX with pool, then it's in terms of SDMX, it satisfies the requirements of both the sender and the receiver. Back to you, David. Again, David and Luca, if you would like to add anything, then please feel free.
Not from my side, so I'll go to the next question. But Luca, you can interrupt me if you wish to. Then the next question is: you mentioned that SDMX 3 will be released at the conference next week. If someone is just getting started with SDMX, do you recommend they use 2.1 or 3 over the next few months?
Yeah, good question. Yes, SDMX 3.0 will be announced, will be released next week. There's going to be a time lag between the time that a standard is created and the time that it is supported in tools. So I doubt that next week we already will have tools that can support SDMX 3.0. It's going to take a while, several months and years for the tools to be developed. So at this time, if you're starting now, and if you need to achieve quick results, then again, 2.1 is much easier to use because you already have that support. If you're starting a couple of years from now, then by that time, there should be a wide variety of 3.0 tools available. And in that case, I think 3.0 would make more sense because it's an improved standard and it will be easier to work with. Back to you, David.
Okay, so the next question is, what are some of the current statistical packages used? I mean, does this mean, I guess this is on tools?
Yeah, I'm not sure exactly what is meant by statistical packages. What I can tell you is that, first of all, there's a wide variety of tools in support of SDMX, of tools that help you create SDMX structures, tools that help you map your data to SDMX structures, tools that help you disseminate SDMX data. And these include SDMX converter, which can be used to get data from text-based and Excel and other data sources and convert them into SDMX. SDMX reference infrastructure by Eurostat that can help you, that lets you connect to a database, map your database to an SDMX DSD and publish that data on a web service quite easily. It includes Fusion Metadata Registry, which enables you to publish your structural metadata on SDMX, that is your structures. And Fusion Registry Enterprise Edition, which is a commercial product that you can use to disseminate your data in SDMX. You have ILO data DSD constructor that can facilitate the creation and management of maintenance of SDMX artifacts. You have the OECD matrix generator that does the same thing in Excel, and a whole wide variety of other tools, which we'll talk about during the rest of the week. If you're talking about statistical packages, what I can mention is that there are modules, there are packages that allow you to interface between, to support SDMX in packages such as R and Python. So if you use R or Python, you can use those packages to easily load the data and process it and then export. Back to you, David.
Okay, thanks. Yeah, just in addition, please have a look at the sdmx.org website tools page, because there are many applications and connectors listed there for things like R and Python, but also like Stata, SAS. Yeah, my mind's gone blank now, but yeah, but many other connectors. There's also coming out next month a connector for Microsoft Power BI to SDMX. So this has been certified. Well, it's available now, but they've certified it. I mean, it'll just be integrated as part of Power BI next month. So yeah, okay. So then the next one is, during the presentation, Abdullah said that SDMX will implement the higher quality for the data. Can he help can he elaborate more on this? Is there any validation process applied in Sdmx?
Thanks for this question. I do have some experience in Sdmx over the last 12 years. The one thing that Sdmx always does is improve the quality of statistical data. It's practically inevitable. And this is what people complain about, strange as it may say, strange as it may sound. The issue is that Sdmx has a very robust validation mechanism. You try to transmit a message, it will check that all the concepts are in place, all the codes are in place, all the codes are valid, the message is logically consistent. Again, as I said, you can impose constraints that will prevent you from sending data on surface area with a breakdown by sex. It doesn't make sense, but Sdmx can prevent that. And the thing is that many complaints arise in connection with this, whether you believe it or not, because people sometimes complain that Sdmx is difficult to use. We used to send the data without a problem. Now it throws errors that we have to resolve. Well, yes, it does throw errors because there are errors in the data. And Sdmx is strict. You cannot send a data set with errors inside it. You must resolve the errors before you can send it. So yes, Sdmx is definitely, I mean, it definitely does lead to an improvement in the quality of the data, and making sure, but increasing the quality of the data comes at an effort. You need to put effort that the data is in higher quality, and Sdmx help you do that. Back to you, David.
Thanks. So we have a couple more questions left. So does Sdmx have a special software?
Sdmx has a ton of special software, ton of special tools, and this is what has made a real difference in the last 10 years or so, or 12. Because these are the tools that help you automate your processes. I started working on large-scale Sdmx exchange in around 2010. And right now, when I look back into 2010 and I compare with what we have now, it's hard to believe how much progress has been made. Back then, when we were implementing data exchange, we had to program, we had to develop every little thing. You want to export your data out of your system, sit down or hire developers that will implement that export, that will program every little thing. But that was 2010. Now it simply doesn't make sense to use this approach, and this is why Sdmx is so powerful, because it lets you create very complex systems without even automate complex processes without even writing code. For example, forget Sdmx. Suppose that you need to to publish your data in an API, right? Application Programming Interface. Think about what it would take with a traditional system. You'd have to engage a developer, you'd have to create a specification, the developer would have to develop the software, test it, publish it. And this will take weeks or months or years. Well, not years, but weeks or months for sure. And just a couple of months ago, I was asked to help one of the sections at UNSD publish their data at an Sdmx API. And it took me about 2 or 3 hours to have the prototype published at an application programming interface. I'm not kidding. 2 or 3 hours, I think I finished it in an afternoon. It did take quite a bit more effort, but why? It's because harmonization. Harmonization, ensuring that we comply with the statistical guidelines, that we use the same codes. Yes, it took a lot longer than the implementation of the actual API. And you don't have to do that, strictly speaking. You could just publish it the way it is. But of course, if you want to do your users a service, if you want to make it easier for them to use your data, if you want to make the data more interoperable, then yes, then you need to spend some effort on harmonization. And this is an effort very well spent. Back to you, David.
Okay, thanks. Yeah, just for this question, it does depend a bit what it means as well, because it could mean several things. So SDMX, I mean, the vast majority of the software that is available is open source and free. Okay, well, it's certainly the vast majority is free. A lot of it is open source, so you can take it and you can adapt it. And there's a lot of software. You know, if you look at the list on SDMX.org, you can see a lot. It's not actually complete. I think that there's other tools that are out there as well. So hopefully we can get those added as well. I think that this is an initiative going on now. But you can create your own software as well. You know, if there's a gap and you really need something, then you can develop something. And there's a how to say, like a class library that you can use to do that called Sdmx source. And you can implement that and you can create a tool relatively quickly using these class libraries. So yeah, well, just one thing, there's like whole platforms as well, like data warehouses, which are free and open source available. I could go on, but I'll stop there. So
yeah, thanks very much, David. Yeah, just a couple of comments. First of all, thanks for mentioning that most of the tools, or almost all of the tools, are free to use. Yes, an important point which I meant to make but didn't. And yes, SDMX at this time, SDMX technologies, they do not cover the entire statistical value chain. That is correct. That is, you cannot just take SDMX tools and automate your entire chain from data collection to processing to validation to dissemination to everything. It covers large parts of it, but not yet everything. So yes, sometimes you do have to write a little bit of plumbing code to connect the different tools with each other, so to speak, or the different stages of the production process. But I think that within a few years, I mean, first of all, you need to do less and less to get there. As more tools become available, there is less and less effort that you need to put into automating your business processes. And with the introduction of a validation and transformation language, a gap will be closed that will, I think, really make a difference in terms of how much effort you need to put into designing your statistical information systems. So with that, we are not even talking about exchange or dissemination anymore. We're talking about the entire statistical information systems, the entire processing. So I think that the situation is already improving, and in a few years, it will be further improved. Back to you, David.
Okay, so let's get to the other questions. So when you say that SDMX will break the siloed databases, does it mean that SDMX is providing a standardized guideline for designing databases?
Where SDMX breaks the silos is basically I mean, if you want to implement SDMX properly, then more or less the different organizational units, they're forced to speak to each other, and even within the organization, agree on common classifications and concepts and codes. This does not happen automatically, but when you implement SDMX, very soon you will be realizing that, hello, you have the same code list, let's say sex, but then your demographic statistics department uses code 0 for male, whereas your social statistics department uses code M for male. And if you publish the data just the way it is, which they are already doing actually, but when you publish this as SDMX, then all these inconsistencies, you will make them visible. And that more or less forces your different departments to talk to each other, and even within the organization to agree on common classifications and code lists. So does it mean that SDMX provides a standardized guideline for designing databases? Not the databases per se, but the data structure definitions, yes. And there will be a session on that, on exactly that on Wednesday. David, I think that you might want to add something here.
Yeah. I mean, because again, there could be several answers to this. So I think what you touched upon is harmonizing the metadata, the structural metadata, Abdullah. But in terms of the technical databases, then yes, I mean, it does Sdmx does help on kind of harmonizing a database or being able to create a database that is usable for all kinds of statistical domains. So for example, like today, your education directorate may have one database, and the labor statistics directorate may have another database, and they're incompatible, or they have kind of some compatibilities, but they're not so efficient. But the Sdmx information model, I mean, really, when we're talking about these platforms that now are Sdmx native, what they're doing, they're built around the Sdmx information model at the technical level. So that means that such a database can house many different types of statistical domains. And there's usually like one data warehouse there. And you can have like efficient web services and for the input of the data and the output of the data, rather than having all these kind of different systems to maintain. And Sdmx has technical notes and standards around how to implement the Sdmx information model. Okay, so if there's anything to no more to add to that, I'll go to the next question. We just have a couple more. So is there a standard or a firm guideline that Sdmx imposes on the documentation of the tools that software developers contribute?
Yeah, that's a good question. I'm not aware of a standard or firm guideline that are imposed on the documentation. There are very firm guidelines on the tools themselves. They must implement the Sdmx information model, which is very well defined. But in terms of documentation, I don't think we have such guidelines. David, Luca, do you know anything about this?
Well, I think, in terms of what contractors have to do in terms of documentation, this is on a per organization basis, and it's kind of outside the scope of Sdmx. But if an Sdmx system is conforms to the Sdmx standard, then there are certain things it has to follow. Like it has to adopt the XML schemas for implementing the information model and for sending data messages around. As you said, Abdullah, it's got to implement the Sdmx information model as well. I mean, there's certain things that it's got to do to be conformant with Sdmx. Otherwise, it's not Sdmx. So and it loses at least some of the advantages in this Sdmx ecosystem. But Luca, do you want to add anything?
I mean, in terms of documentation requirements on a new piece of software, this is, as Abdullah and David mentioned, this is often it often depends on each organization and whatever standards they have for software in general. But indeed, the Sdmx tools need to follow, let's say, the schemas and the structure specifications specified by Sdmx. And an interesting aspect of this, and that I just want to raise, that the technical working group is working on, is a technical compatibility kit, which would allow, which is currently useful especially for web services, that allows to test whether an Sdmx web service is indeed Sdmx compliant, or to what extent it is Sdmx compliant. So there are some tools or some frameworks that have been made available to the technical working group to assess whether certain software is Sdmx compliant. Yeah, that's what I can say so far.
Yeah, I mean, the main thing for our systems Sdmx compliant, the main place to look is the sdmx.org standards page, and I'm just putting the link into the question. And there's several kind of parts of the standards there to check conformance and to see how to implement as well. Okay, so we've got some more. I don't know how we're doing for time, but okay. So the next question is Sdmx 3 compatible with the Sdmx 2? Well, I'd say this is quite a kind of broad question that I think is going to be covered somewhat on at least the first day of the global conference. But do you want to say anything on it now, Abdullah?
Well, I mean, it's backward compatible, I believe, right? The information model is backward compatible in the sense that you can take an Sdmx dataset in 2.0 and transform it into 2.1. So that basic compatibility is preserved. But then certain formats have been discontinued because they're hardly used anymore. And certain features, such as, for example, SOAP API has been discontinued. But at the data level, in terms of the data set, you can take you will be able to take an Sdmx 2.0 data set and transform it into 3.0, but not the other way around, because 3.0 has many more features than 2.0. Right, David, Luca?
Yeah, I think that's a good answer for me. So the next question, I think, is a comment, just a mention of some econometrics tools like SPSS, Stat, R, MATLAB. So I'll go to the next question. What are the tools to create Sdmx metadata? And this is the final question.
Structural metadata or reference metadata? If we're talking about structural metadata, there are many tools to create them. And these include, and you will see some of them, these include ILO DSD constructor, OECD matrix generator, Fusion metadata registry, Fusion registry, just to name the most widely used ones. If you're talking about Sdmx reference metadata, which is basically the data on methodology, quality, and all that, there really is a dearth of tools on that. And there will be a presentation. Actually, I will be delivering one of the presentations exactly on that, on our pilot reference metadata exchange for SDG indicators. There are very few tools that support that. The one I can remember off the top of my head is Fusion Registry Enterprise Edition. And even that, well, to some extent, Fusion Registry as well. But even that support is limited. So it's much more difficult with metadata than data. Okay, back to you, David, and I think that then if you please add any comments if you have, and then we'll take the final question and go for a break.
Okay, so the last question is, sorry, did you say one more question? Or?
Yes, we'll take the final question and then we'll break. Okay,
so will there be major changes to the REST API as a result of the welcome introduction of Sdmx 3?
Yes, there will be changes to the REST API, which will improve its functionality. And I think that on Monday, if my memory is correct, next Monday, as part of the Sdmx Global Conference, there will be a discussion on that as well.
Okay.
Okay.
Okay,
so,
and just a very last one as just a comment to say we have developed a quick VBA tool for reference metadata. And this is a comment from Vilash Mandlika. Sorry, I hope I've said your name correctly. So that was a final comment.
Thanks very much. So thank you very much, everyone. I think the introduction session in the end took quite a bit longer than we thought, and we are actually on schedule instead of be ahead of the schedule. But I think that this was money well spent. Not money, time well spent, but we know that time is money and money is time. So yeah, it's more or less equivalent. So let's go for a break now. We have about 7 minutes before 10:45 Mexico time. So let's get back at 45 minutes after the hour, and we'll start a presentation on the basics of data modeling. Thanks very much, everyone. We'll break now, and please stay with us and come back after the break. Thank you.
So Abdullah, is that a 10-minute break?
Let's come back at 45 minutes past the hour, 10:45 Mexico time. Thank you. Once again, good morning, good afternoon, good evening, everyone. And
Yo me metí en mi celular.
I suggest we move on to the next presentation. Please mute yourselves. Okay, thank you. David, Luca, you ready?
Yes, I'm here.
Okay, excellent. So let's start our next presentation. On the basics of data modeling, or Sdmx information model. David, can you see the presentation?
Yes, it's fine.
Okay, thanks. So the basics of data modeling, introduction to the Sdmx information model. Typically, we spend more on this presentation than the time we have now due to the virtual format of the capacity building session. So we'll have to go quickly through it. It's got 52, I think about 52 slides. So we'll go quickly. Please ask your questions in the Q&A box. We'll try to answer as many as we can. Also, I will pause at certain times when it feels appropriate to answer your questions. And we will also have some quizzes, Mentimeter based, so that you can assess your own knowledge of Sdmx. Okay, so let's go. So it's important to understand that we're talking about figures or data. By themselves, a figure is meaningless. So we have a figure 2529, but we have no idea what that is. And what do you think is it? Let's see. Oh, we know it's a number. Tourism establishments. Is this the number of tourism establishments? Okay. Yes, it's the number of touristic establishments in Italy. And we also know it's annual data. Oh, it's not just any touristic establishments, it's tourist campsites. There we are. So it turns out that 2529 is the number, or was the number, of tourist campsites in Italy in 2004. Okay, so it's good to have a piece of data such as 2529, but if we want to use this data, it needs to be properly described. And these descriptions, they let the users know what the data actually is, what it represents. So when we exchange data, statistical data between two parties, we always need to develop a data model. I mean, you need a data model with Sdmx, without Sdmx, with pen and paper, with a typewriter, with a computer, with a web service. You still need a data model. And in Sdmx, this data model is represented by a data structure definition, or DSD for short. So the DSD, it provides descriptions for all relevant characteristics of the data to be exchanged. The keyword, one of the keywords here actually is relevant, because statistical data can potentially have a very large number of characteristics, but we only need to determine and use the relevant characteristics of this data. Now, developing a data structure definition is not similar, but is similar and different from developing a relational database. In some aspects, it's similar. In other aspects, it's different. But in many aspects, it is similar to developing a relational database. A relational database that has a star schema. So the first step in designing a GSD, we need to find concepts that identify and describe our data. So what's a concept? Unit of thought created by a unique combination of characteristics. Well, that's a rather intimidating looking description, but basically each concept is a characteristic or more characteristics, one or more characteristics that describe the data. So for example, if we were describing a person, we could come up with such concepts as age, sex, color of eyes, height, and so on. When we deal with statistical information, we deal with concepts such as reference area, sex, occupation, seasonal adjustment, and all the other concepts, all the other characteristics which are present in the world of statistics. All right, so let's have a look at this statistical table, which is an excerpt from the African Statistical Yearbook. So which concepts can we identify in the table? First, let's have a look at this one. This is our indicator. We always have an equivalent of, it may not be called indicator, but we always have an equivalent of a concept that says what it is that we are measuring. In this case, the indicator is total mid-year population. What then? Country. Country or reference area. In Sdmx, the concept name used for territory is reference area. Obviously, that's always present in statistical data. It's an inherent concept. And then what? Time period, of course. Time period. We need to know what time an observation relates to. And so we have reference area, which is spatial characteristics, and we have time period, which is the time characteristics. Space and time always present in statistical data. And the indicator, which tells you what it is that we are measuring. So together, indicator, reference area, and time, they are kind of the minimum set of concepts that can be used in a data structure definition. But that's not all. Look at this. Unit multiplier. If I ask you what the population of Swaziland was in 1999, and you look at this table, you might decide that this is 910. That in whole of Swaziland, 910 people lived in 1999. Is that true? No, of course it's not true. But unit multiplier tells us that this is not 910 people, this is 910,000 people. So also very important characteristics of the data. And finally, we need a concept to represent the values themselves. And this concept in Sdmx is by convention called observation value. So when we have these 1, 2, 3, 4, 5 concepts, we can describe the data present in the table that represent all the relevant characteristics. All right, so we found our concepts: indicator, reference area, time period, unit multiplier, observation value. But in Sdmx, starting version 2.1 and also in 3.0, concepts don't live by themselves. You cannot declare a concept. A concept is only declared as part of what's called a concept scheme, right? So the concepts, indicator, reference area, they are not maintained by themselves. A concept by itself cannot be put into an Sdmx message, but we have a list of concepts concept scheme, which is maintained as a unit and which can be transmitted in an Sdmx message. All right, so now we know we have determined the concepts that describe our data, but we have 5 of those, right? Right, 5. But which of these concepts are used to identify an observation? Which of the concepts can be used to locate an observation in the table? And these are the same 3: indicator, reference area, time period. When we know all 3 of these, then we can unambiguously locate an observation in the table, and these concepts are called dimensions. If you are familiar with relational database design, then the role of dimension is similar to a database table's primary key field. Typically in Sdmx, you have multiple dimensions that compose a key. We'll talk about that later. And each of the components of this key is a dimension. Indeed, if we look back at our table, you can see that in essence, what we have is a table with coordinates, sort of X and Y. In this case, we also have a Z indicator, and we know that there are other indicators in this publication. We just don't see them on the screen. When you know all 3 of these, you can locate an observation in the table. So if we know indicator mid-year population, reference area Swaziland, year 1999, then we know that this is the observation for that country and that year, 910. Dimensions are in essence coordinates. In this case, you only have 3. Typically, when you deal with Sdmx, you have a hypercube with 5, 6, 7 or more dimensions, and sometimes it can be a very large number. Okay, these are the dimensions. The second type of concept in Sdmx is an attribute. So, unit multiplier. Does it help you if I tell you that unit multiplier? If I tell you that unit multiplier is 1,000, does it help you to locate an observation in the table? No, it doesn't. It's not used to identify a series or observation. It is not a coordinate in a hypercube. And these concepts are called attributes. Now, we already looked at that example. Attributes convey vital information that help us understand the data. No, they're not dimensions. No, they don't define a hypercube, but without the attributes, we would think that the population of Swaziland in 1999 was 910 people. That's clearly wrong. Attributes help us correctly interpret the information. They provide vital additional information about the observations. The role of attributes is similar to the role of a database table's non-primary key fields. They don't define, they're not used to identify an observation, but they can be used to, but they convey additional information about a database record. Okay, so we had dimensions, we had attributes, but we also had the observation value, which is neither a dimension nor an attribute. In Sdmx, this dimension is called primary measure. In our concept scheme, observation value, it represents a concept that describes the actual values which are being transmitted. And in Sdmx parlance, this concept is called primary measure. In Sdmx, by convention, the primary measure is almost always represented by a concept with ID OBS_value that stands for observation value. Okay. You might ask why it's called primary measure. It's because there is some support for multiple measures in Sdmx, which will be further expanded in Sdmx 3.0. But in most cases, especially when we deal with aggregated statistics, which Sdmx was designed for originally, there is one measure in a data structure and it's called the primary measure. So this is the use case that we'll focus on. Now, what's important to understand is that when you design a data structure definition, whether you designate a concept as a dimension or attribute, it has large implications on the structure of the data. If a concept is used to identify an observation, it should be made a dimension. And if a concept provides additional information about an observation, that should be made an attribute. If a concept is a dimension, then you can have separate, distinct series, which are different only in the value of this concept. The example that is given here, suppose you design a data structure where unit of measure is a dimension, right? Then you can have separate series, separate sets of data for tons and tons per hectare, which could be a valid use case, right? So if you are collecting data on the harvest, tons will give you the amount of harvest, whereas ton per hectare will give you the yield, the average yield of. But if you're not careful, you can run into a situation where you also have separate series for kilograms and tons. And that probably is not a good thing, because if you know an observation value in tons, then you can very easily convert it into kilograms. So this is why you have to be careful. You want to know that you have correctly identified the role of the observations and that you have, the role of your concepts, and you have correctly defined the representations of those concepts. So let's have a look at this in more detail. All right, so we have this small data set with only 3 observations. What we have here is the number of fixed and mobile telephone subscriptions for Cambodia. And we know that in the year 2012, the total number of telephone subscriptions was 19.7 million. In 2013, it grew to 20.6 million. And we also know that in 2013, the number of subscriptions per 100 people in Cambodia was 140.9. So let's develop a data structure definition to represent this data set. All right. So here, as you can see, we have a data structure with 6 total concepts, of which 4 are dimensions. We have dimensions reference area, indicator, time period, and unit of measure. And then we have an attribute unit multiplier, and we have the primary measure observation value. So our dimensions are reference area, indicator, time period, and unit. Is there anything wrong with it? No. This is our structure, and it can be used to adequately represent the data set above. So this is good. But now suppose that instead of designating a unit of measure as a dimension, we made it an attribute. And so you have a picture that looks almost the same, a table that looks almost the same, except unit of measure is no longer a dimension. Here it is an attribute. So what changes? Is anything wrong? Yes, there is wrong. I mean, there is a problem with this data set. Remember, dimensions identify an observation, right? Unambiguously identify an observation. And that means that if we know reference area, indicator, and time period, we should be able to unambiguously locate an observation. All right, so this is our key. Reference area Cambodia, indicator, fixed and mobile telephone subscriptions, time period 2013. And what happens here is that this key, this combination of dimensions, matches 2 observations, not 1. And that's a problem. We have a duplicate. This key, the complete key, is supposed to always return 1 observation. It returns 2. That means that these 2 observations are a duplicate. And this is a change. This is what a change in the role of the observation has resulted in. We changed the unit of measure. We changed its role from dimension to attribute, and we now have a duplicate observation in the data set. So suppose that our dimensions are fixed. What can we do about this? If you look into this data set, you see that the unit of measure is still an attribute, but we added an indicator. Now we used to have a single indicator, fixed and mobile telephone subscriptions. Now we have a new indicator, fixed and mobile telephone subscriptions per 100 population. And now we have no violation because every row has a unique key. If you look into the values of reference area, indicator, time period, you will see that they are unique for each row. We have no violation, we have no duplicate, it works. I think let me pause here and take any questions. If you have any questions, please type them now. I will try to answer them now. David, I don't see any new questions, right?
No, I can't see any.
Okay, there is one.
People are. There is one now. Is there a generic term for dimensions and attributes?
Yes, concept. A concept can be a dimension or attribute, and it can also be a primary measure. All right, so in the interest of time, let's move on. But again, if you have a question during the presentation, please type it into the box. And then when we pause for answers, I'll be happy to answer it at that time. All right, so let's go on. Now, attributes. Dimensions, they define your grid, your coordinate, or not a grid, really, a hypercube, actually. Attributes, unlike dimensions, they can be attached. That is, you can specify where this attribute applies to what it applies. So in Sdmx 2.1, we had attributes attached at observation, time series, or group, or a dataset level. Group is a group of dimensions, a reduced number of dimensions. In Sdmx 2.1, you can attach attributes to observation, a group, a dimension group, and the data set. One of these. That is, there is no explicit attachment to time series. However, if you attach observations, if you attach an attribute to all dimensions except time, then what you're effectively doing is attaching the attribute to a time series, because all dimensions except time give you the time series key. Now you have this variety of possible attachments, but for practical purposes, most often attributes are attached at observation or time series level. Sometimes at the data set, but most of the time it's observation or time series. All right, so we've talked about concepts and their roles, dimensions, attributes, primary measure. A question that's often asked: how do you identify your concepts? How do you find them? Well, you identify the concepts by analyzing your data set, which is what we have just done with that with the table we had. But in examples of any complexity, you have a wide choice of, I mean, very often it's not clear how, first of all, what are the concepts in your table, because you can approach that from different angles and get a different set of concepts. And second, how do you name those concepts and how do you identify them? Well, to help you, the Sdmx Statistical Working Group develops and publishes so-called cross-domain concepts. These are concept and concept IDs, which are common between statistical subject matter domains, common between different areas of statistics, and can be de-used in many data structure definition. You can find the full list of cross-domain concepts if you follow a link, and the link on the page, and the cross-domain concept scheme is also published at the Sdmx Global Registry. So if you open the list of cross-domain concepts, you will see what? You will see that there is a concept, there is a definition for statistical indicator, and there is an ID for the concept indicator. There is a definition for reference area, and there is an ID, ref_area. There is a concept for sex, age, unit of measure, unit multiplier, and all the other ones. So when you're designing your data structure definition, it's a good idea to have a look at the cross-domain concepts to see if concepts for your structure, for your data set, have already been defined. And if they have, it's a good idea to reuse these IDs as much as possible. Why? One is it makes your own job a little bit easier. Second, it improves the interoperability of your data, because if you use standard cross-domain concept IDs, then the software that processes your data, it might be aware and it might correctly identify and use these concepts, both software and humans. All right, so if we look at our data model, what do we see? We have 5 concepts, and each of these has an ID and a name. So for the first one, we have concept indicator and the ID indicator. We have a concept reference area and ID ref_area, concept time period, named time period, and ID time_period, unit multiplier, observation value. Of these, 3 are dimensions: indicator, reference area, time period. We have 1 attribute, unit multiplier. We have the primary measure, observation value, and we attached the attribute unit multiplier to time series. So if we look at the concepts, we have indicator, we have the name and ID. Please know that name are for your use, for human use, and ID is for machine use, for the machine consumption. IDs are extremely important. They are the ones that are standardized. So please be careful with your IDs when you design your data structure, your concept scheme in this case. And by convention, concept IDs, like all IDs in Sdmx, are uppercase, and underscore is used to separate words or abbreviations. Before we go on to the first quiz, I'm calling again for questions.
There are no questions so far.
Good. Oh, good. Oh, yeah, there is.
Like...
Okay, no questions.
All
right.
Well, so, hang on just a moment, sorry. So somebody asks, So like examples just now, it means that the dimension row should be unique.
First of all, please type your questions into the Q&A box. If you type them into the chat, then we might not notice that. Well, once again, dimensions help us identify an observation. It means that for each observation, you have a corresponding unique combination of dimensions. That's what it means. You cannot have duplicate combinations of dimensions in your data set. This is what happens here. In this data set, you have two identical combinations of dimensions. And this is a violation because in essence, you have a duplicate observation. The system will look into this data set and it will be unable to say which of these observations, one is 20.6, the other one 40.9, which of them is the valid one. So yes, the combinations of dimensions in the data set must always be unique. And if you're again familiar with the relational database design, the combination of dimensions is your primary key. Back to you, David.
Yeah, okay, there's another question. Is a data model used to create a DSD?
Well, yes. You design a data model, and in Sdmx, a data structure definition, a DSD represents the data model. You can create a data model and then develop a relational database for it. And you can create a data model and create a DSD for it. So that's how it works.
Yeah.
All right.
I guess, yeah,
Yeah,
I
go
guess
ahead.
a full data model, could be more than a data structure definition, because a data structure definition, it structures a data set in Sdmx, like how we say that's a cube. And this is how you exchange data messages. But I guess a full data model in Sdmx are things like code lists as well, and the concept scheme, and it can be other parts of the information model.
Yeah, well, it depends on how you how you view the DSD, whether it includes them or not. But also, what is actually also true is that eventually, after you create your data model, you can decide that it's best suited by several DSDs, more than one. So yeah, this is also an important point. Yeah.
Yeah, just to say as well, we're going to touch more on this in the best practices for DSD creators, and we'll see, more aspects of the data model, the things that surround the DSD that are kind of required really to create a DSD.
Back to you, David.
No, that's it. That's all the questions.
Okay.
Oh no,
okay,
sorry. There are some more. If we've got time. So please explain the group. Is it a collection of indicators within a data set? And give example of a group to which an attribute is attached.
Group, again, we'll talk about that very briefly a little bit later. Group is, what's it called? Partial key. It's a group of dimensions, but not all dimensions, right? So you can pick, let's say, indicator and reference area, and then you can attach your observations to it, to that dimension group. It's not very widely used in Sdmx until now. Probably is going to be used more extensively in the future, so I don't want to spend too much time on that. But this is the idea. Group is a partial key. You pick one or more dimensions, but not the entire, not your entire dimensions, and then you can attach metadata to it, such as attributes. Back to you, David.
Yeah, I mean, could we say that one of the more common examples of a group is like a series group, which is like all of the dimensions apart from the time dimension, and this is often used to attach like attributes such as unit multiplier. Yeah. So you're not attaching that information at every single observation, which would take a lot of space in the data message, but you're you attach it to the series to say this series has this unit multiplier.
Yep, absolutely. As mentioned, if you attach attributes to a group of dimensions that includes all dimensions except the time dimension, then you're attaching it to the time series. Okay, let's answer one final question and go into the quiz.
Okay, so what is the difference between a DSD and a MSD, a data structure definition and a metadata structure definition?
Well, data structure definition is your data model. It is used to create data sets in conformance with the data structure definition. It is used to validate the data set. It is used to transmit the data set. Metadata structure definition defines a structure for your reference metadata for things like methodology, quality aspects, data sources, and all that, which in Sdmx 2.1 is transmitted separately from the data. We'll talk about that later. I don't want to spend time now because it's part of this presentation. All right, and now let's go into the quiz, and we'll try to answer the remaining questions at the next Q&A session. So now I'm stopping the sharing and I'm giving the floor to Luca.
Yes, hello everyone. I will be running the quiz. So let me just share my screen. There we go. So you should now see in front of you a slide, which is built with a software called Mentimeter. And the way this works is quite simple. I'm going to show you in a few minutes, in a few seconds, the question. And in order to answer the question, you have to go with your PC, tablet, phone, whatever you want, to www.menti.com and insert the code that you see on the screen, 71750241. I see a bunch of people have already connected. Each person is an icon. I'm not sure you get to choose your icon. So we're going to wait for a few of you to connect, and then we're going to start the quiz. Okay, I see 25 people are connected now, 26. So once again, in order to participate in the quiz and test your knowledge, go on www.menti.com and use the code 71750241. You can actually join at any time. So if you have some trouble right now, don't panic. You can join the quiz also for later questions in case you missed the first ones. Abdullah, let me know when you feel it's that we can start.
Yeah, I think we can start. Again, please go to www.menti.com and use the code 71750241.
Exactly. Okay, we have about 7.
Yeah, you can use your phone, your tablet, your computer, anything. Thanks. Okay, back to you, Luca.
Okay, we have about 75 participants. I think that's enough. Once again, if you missed the first questions, you can join at any time. Just follow the instructions here. So let's go. First question. So you will be shown a quiz and you'll have some time. And the question here is, you have this data set here. What concepts take the role of dimensions? So you have a data set here. The data set is called share of temporary employees by sex. It has a number of concepts. And the question is, what concepts take the role of dimensions? You have 4 options, and you should be able to, on your tablet, phone, how are you connected, to choose the option that you believe is the correct one. And you still have 2.5 minutes to make your decision. And then we'll see the final results. And Abdullah will tell you why you were wrong or why you were right. Once again, if you're just joining now and want to join the quiz, just go to www.menti.com and enter the code that you see on the top of your screen. I see 30 people have answered already, but we had more than 75 participants. It means that still quite a few of you need to answer.
How did it go?
Okay, so 45 seconds left. I see most of you, I think, answered. We have 75 answers so far. Once again, the question is, in this data set, what are the concepts that take the role of dimensions? And we have 4 possibilities. There's only one right answer here. Okay, 10 more seconds. If you're still undecided, it's now or never. 3, 2, 1, and let's look at the results. Interesting. Abdullah, what do you make of this?
Okay, so we had 27 correct answers and 54 incorrect answers. I think exactly 1/3 correct answers. All right, so let's see. Luca, can you bring back the data set?
That's a good question. Not sure I can.
Okay.
So
give me a second.
Yeah.
Maybe I'll share my Excel. 1 second.
Oops.
All right, so let me share my screen. I think, Luca, you'd have to stop sharing, or yeah.
There it is.
Or
all yours.
Yeah, thanks. All right, so it wasn't a very easy question, admittedly. What we need to know looking at this data set is which concepts help us identify a dimension in the table. So if we look at this one, what do we need to know to locate an observation in the table? We have an indicator. We do need to know if, okay, fine. In this case, we only have one indicator, but we can imagine that there are more than one. And an indicator, its equivalent, is always present, as I said, in a data structure definition. Right? So which dimension, what do we need to know to identify? Suppose that we have a dimension, we have an observation 21.4. Which concepts help us identify this observation? We need to know the indicator, we need to know the country, we need to know the year, and we need to know the sex. Indicator, country or reference area, sex, and time period. That gives us the observation, that gives us the coordinates, the dimensions that we can use to identify this observation value. Now, what about source? Well, the question is, if you look at this data set, you can see that the source is the same for each country. Each country's data is not broken down by source. Source does not help you identify a dimension in the an observation in the data set, because if you know because it is sufficient to know the country. Now, obviously, you have to make some assumptions. So, for example, I mean, in this case, we can know that the source depends on the country, because this is logical. This is the assumption that we make. Instead of a country depending on the source, we have a source that depends on the country. And this is why country is chosen as a dimension. And again, every data structure definition will have a spatial dimension, reference area, whereas source is not a dimension here. And but this was admittedly a not very easy quiz. Something else which I would like to mention is that you also have other dimensions in there. For example, frequency. Do we have a concept frequency? Yes. And here we have an indication that this is annual data. You had frequency in all 4 answers. And it's a good idea to create frequency in your data structure definition, because in Sdmx 2.0, this was a requirement. In Sdmx 2.1, it's not a requirement, but it's still a very good practice to include frequency dimension in your data structure, even if your data set is not broken down by frequency. Even if all of your data set is annual data, it's good practice to create dimension for frequency. But again, frequency was present in all the answers. Something else to note, here we have a country, and among the dimensions we have reference area. Why? It's because, as mentioned, reference area is a cross-domain concept. And it's very good practice to use cross-domain, to use the standard identifiers for your concepts. Similarly, instead of here, we use the identifier time period, and instead of the value, we use observation value. Back to Luca, and David and Luca, please free to make any comments if you'd like, if I missed anything.
Not on my side. I think we can go with the next question on the quiz, if you allow me to share.
Yes, just one comment. When you look at these questions, they're designed to be not terribly complex. And if you use the strategy that always filter out the wrong, I mean, you'll always have answers which are clearly wrong, and it's easier to throw them away and focus to all those that are possibly correct. And it shouldn't be terribly difficult to identify those that are correct. Okay, now back to Luca.
If I could just say, yeah, I mean, I think for that question, it's not completely clear whether source should be a dimension or an attribute. I mean, I think, as you said, you have to make certain assumptions or know something about the underlying statistical domain to really know that.
Yes, that's the challenge of having it in a Mentimeter quiz versus a kind of a full-blown exercise where you can present a large data set with more and make it clearer to the user. Okay, back to you, Luca.
Okay, so now you should see the Mentimeter quiz again on the screen, and we're going to go on to the second question. You don't need to do anything. If you have disconnected, you can reconnect. I see 70 of you are still connected, so you don't need to do anything. You can just keep connected. For those of you that may be disconnected, just log in again, put the same number again, and you'll be reconnected immediately, and you'll be able to participate in the second quiz. Once again, if you missed the first quiz, you can still take the second quiz. It doesn't matter. You don't need to have taken the first one to take the second one. So we have about the same number of participants that we had before. So I think we can start. Oops, sorry. I skipped ahead. There we go. Once again, it's the same. You actually have the same data set under your eyes, but the question is different. It's what concepts take the role of attributes? And here you have different options. Once again, 4 options, but this time, since you already saw the data set once, you only have 2 minutes. So please put in your answers, and we'll see how you do at the end of when the clock runs down. Once again, we're working with the same data set as before, but this time we're not looking for dimensions, but for the attributes. And you can probably make use of some of the explanations that Abdullah made in explaining the answer to the previous quiz to help you out in figuring out what should be the best answer. Okay, 15 seconds left. I think about 5 of you still have not participated, probably. There you go. Number is going up. 10 seconds. Once again, answer now or forever hold your peace. And let's see the results. Much better this time, Abdullah, it seems to me. Well, better, at least.
Yes, better. Still less than half, but I think the plurality of participants gave the correct answer. All right. Now, if we look at these 4 options, options 1 and 3 have observation value among the attributes. And these you can immediately throw away because observation value is the primary measure. Observation value does not take the role of attributes. It's the primary measure, as we talked about. So these 2 answers you can throw away. And then we have unit of measure and unit multiplier and source. Now, the difference between 2 and 4 is that 4 does have source, and option 2, unit of measure and unit multiplier, doesn't have source. Now, why is option 4 correct? It's because it does have source. Because remember, we have dimensions, attributes, and the primary measure. The primary measure is the observation value, right? So then we have the remaining concepts. And if you don't designate source as an attribute, then that means it's not part of the GSD and it's not part of the data set. So you are not transmitting it in the first place. Right? Therefore, the correct answer is 4. Source is an attribute. It's not among the dimensions that we had in the previous exercise. It's not the primary measure, And if you wish to transmit it, then you need to designate this as an attribute. All right. Back to you, Luca.
Okay, so now comes the third and last question of this set. We will have a few more questions later. So once again, I see most of you stayed connected. That was a good choice. If you need to reconnect, go on www.menti.com and type in the code that you see on the top of the screen. But it seems that most of you remain connected, so I would suggest you just start the countdown. And once again, you're working with the same data set, but this is a question about attachment level for the attribute source. So we determined already with the previous question that source is an attribute. And as Abdullah mentioned in his presentation, attributes need to be attached to something. They can be attached to different levels. And yeah, you have 4 options, once again, to which you can attach the source attribute, and you have to choose the best one. I think, Abdullah, out of the 3 first questions, this is maybe the trickiest one.
Yes, because the question here is the most appropriate, because in principle, there's more than one correct answer. So you need to pick the one which is arguably the most appropriate.
Yeah.
Just a quick question. Did you describe what a data set is?
Well, this is the data set, the table on the screen. Yeah. But a more formal description of the data set will come later.
Indeed, indeed. I mean, in this case, at least you have to assume that the data set is what you see on the screen. Okay, you have about 10 seconds left. I see that there are still a few people who are hesitating. Come on, last few seconds, put an answer. Let's see the results. Okay, well,
yes, still a plurality.
Still a plurality, the same plurality as before, and this question to me was much trickier. So yeah.
All right. So first of all, let's describe which one is clearly wrong. The one which is clearly wrong is dataset. Because remember, if you attach it to the dataset, then the attribute must be the same for the entire dataset. And here we have different sources. Therefore, okay, actually, I think that I will need to display the table again, Luca.
Please, I stopped sharing.
Yeah. Yes. So if we attach the attribute to the data set, then you have a single string, a single attribute value, which is attached to all the data in the table. And here we can see we have more than one. So this is clearly wrong. But then we have group, observation, and time series. Can you attach this to a group? Yes, you can. It's just that, as mentioned in the presentation, attachment to a group is not very widely practiced because it's not supported very well in tools and for other reasons. But in principle, you could attach it to the group. And then we have observation or time series. Can you attach this to the observation? Yes. In this case, actually, the way it is displayed, you have how many? 9 observations, and you have 9 values of the source attribute. So you could attach it to the observation, it would work. But if you look into it, this is the same value of the attribute is attached to the entire, to all the data for a single country. If you attach it to the time series, which is basically, that means you're attaching it to a reference area and sex, then you don't have to repeat this attribute for every observation. You can attach it just to country and sex. So instead of transmitting 6 observations for Albania, you will only be transmitting 3. And this is actually an important question, which unfortunately we cannot dive deeper into because of the limited time. But if you attach an attribute to the observation, it will always work, because observations is the lowest unit, the lowest level at which you can attach it. So you can always attach all the attributes to the observation, it will always work. But if you do attach it to the observation, then that means that the value of the attribute will be repeated for every observation. Whereas if you attach it to a higher level, then if you know that the value of this attribute is the same for a set of observations, for example, those that belong to a time series, then you only need to transmit it once for that time series. And that improves your efficiency, which is why the correct answer is it's more efficient. I mean, you can attach it to the observation or time series, but it's more efficient to attach it to the time series. But again, here there was more than one correct answer. And attaching it to the time series is kind of the most appropriate in line with the current practice. But if you selected group, or if you selected the observation, this is not wrong. It's just probably less efficient than, I mean, either because of its lack of supporting tools or because of the repetition than attaching it to the time series. All right.
I think this concludes the first part of our quiz. We'll have some other questions later. So if you're connected to, or you have the page with the quiz open to answer, you can keep it open. Otherwise, you can reconnect later. Thanks, Abdullah.
Yeah, thanks, Luca. Let me share the presentation again. Oh, this one. All right, somehow. Let me scroll. Okay. All right, so we went through the first questions: identify dimensions, identify attributes, and identify or determine the appropriate attribute attachment level. And you can see that even with this very small and simple data set, it's still difficult to figure out the dimensions and attributes. And moreover, you need, when you do identify those dimensions and attributes, you need to make certain assumptions that influence your decision. And although we try to bring this number of assumptions to the minimum, still, it was difficult for the participants, although I'm happy that a plurality, if not a majority, did solve the last 2 exercises correctly. And now, because it's so important, this topic, I will take some questions. So David, I think that, yeah, we can continue from where we stopped.
So the next question from where we stopped last time is regarding on dimension and attributes. In the case of unit of measure concept, whether it is set as a dimension or attribute decided on the kind of database table or schema, like is the column a primary key or not? Is there any consideration on deciding a concept set as dimension or attributes? Yeah, I've just read it out, but so it seems like, so is unit of measure, how is it decided as a dimension or an attribute?
Okay, thanks. Thanks, David. All right, there are several questions I think rolled into this one. If it's a general question whether unit of measure should be a dimension or attribute in general in a data structure definition. I don't want to go into this here because this is a very hot topic that has been debated in the Sdmx community literally for years. And the best answer I can give you is that depending on your situation, depending on your data set, you may decide that unit of measure should be a dimension or sometimes should be an attribute. I think that the key question here is how tightly your indicator linked to the unit of measure. If your assumption is that indicator has an intrinsic unit of measure built in, then unit of measure should be an attribute. Whereas if you decide that an indicator can be broken down by possible different units of measure, then it should be a dimension. Is it decided on how the database table schema is, whether it's a column of the primary key? It can help you decide whether it's a dimension or attribute when you design your data structure definition, but this is not the final answer. That is, if in your database the unit of measure is a dimension, is a primary key, part of the primary key, then that gives you a stronger case to make it a dimension in the DSD, but this is not the only factor. You may want to look at other factors as well. For example, interoperability, and then you may decide to make it an attribute in the end. And moreover, it can easily happen that you have a situation where the unit of measure is an attribute, or let's say is a non-primary key in your database, but it is a primary key in the data structure definition to which you're mapping. This is possible. These situations can be expected. They are supported. Okay, back to you, David.
Yeah, so we're going to touch on this again in the best practices for DSD creators on Wednesday, but also in the main conference, there's a presentation on modeling unit data, where we give like we're working on a kind of proposal in how to harmonize the modeling of unit data at the OECD, and this will be presented where we break the unit of measure actually down into several concepts. So you may be interested in that. So the next question is, can one data source be mapped to multiple data models?
Excellent question. And I'm very happy that this has been asked. And the answer is a definite yes. You can have your database, which is mapped to several data structure definitions quite easily. Whether it's good or bad is a different topic, but it is possible that, for example, you create a, you want to design a data structure definition for your dissemination, you create a DSD, and then you map your database to it. And then a couple of years later, a global DSD for the same subject matter domain has been approved, right? Which is almost certainly different from the DSD that you have been using. Then you can map the same database to that other global data structure definition and have a separate data flow for reporting. In this case, you have several data flows for reporting and dissemination, which use different data structure definitions. Fine, nothing wrong with it. Back to you, David.
Yeah, but this is kind of at the heart of Sdmx actually, because Sdmx, it has something in the information model, a kind of artifact that you can create for a mapping that actually describes a mapping called a structure set. So you can define a structure set which describes, the mapping between two different data structures, and you can store it in a registry, and you can reuse this and even share it, with others. And you can have several of these mappings as well. But also what you can do in Sdmx is like you can, if the data structure is your DSD, so you store the data in a cube, then you can also present that data in several ways using data flows. I mean, at least this is what we do at the OECD. So you can have a kind of dissemination data flow, you can have a reporting data flow, and you can have several data flows. And basically they're coming from the same data. You're not duplicating the data for each kind of representation you want to make of that data. So, yeah. Okay, so the next question is, may you send to mail the record of the class this session? Well, yes, we're recording all of the sessions, so I believe these will be distributed after the sometime after the presentations and the training. Then just, yeah, that's it. The last one was a comment. So please, back to you, Abdullah.
Yeah, thanks very much, David. We are falling behind the time. We have very limited time left, so we have to kind of speed up a little bit. But what we have described, what we have talked about now is very important. So I think it was time again well spent. So we'll have to go faster for the rest of the presentation though. All right. So we have determined our concepts. We have determined the roles. But now, how are these concepts represented? When you create a data message, what do you put into it to describe the data, right? And this is called representation. In a data structure definition, you describe which values are valid for each concept. And when you transmit a data message, each concept must have a valid value. So in Sdmx, you can have 3 types of representation for a concept. A concept can be coded, that is, it can have a code list attached to it. It can be formatted, that is uncoded, but you specify a valid format for the concept. And finally, uncoded with free text. Free text, any text will go. So let's start with the coded ones. What is a code? Language independent set of letters, numbers, or symbols that represent a concept whose meaning is described in a natural language. If we're talking about codes, we have them in daily life. They surround us everywhere. And why is it important? For several reasons. One reason is language independence. If I tell you, let's say, Joseph Kennedy International Airport, that might not tell you much if you don't speak the English language, right? However, if I give you the airport code JFK, then you can look it up, the number of, sorry, not the number, the name of this airport in any of the available languages. So that's the first thing that codes give you, language independence. We talked about Sdmx and how and the concept scheme specifically, and we talked about how concepts don't live by themselves. They can only exist and be transmitted as part of a concept scheme. Similarly, the code, a code does not live by itself. It only exists as part of a code list. And what's a code list? It's exactly what it says, a list of codes which is maintained as a unit. And a code list enumerates all possible values for a concept or a set of concepts. So you have a concept sex, and you have a code list for sex. You have a code list for reference area, and you have a reference area code list, indicator code list, and so on. So these are some of the examples of code list. And some of them are taken from the SDG data structure definition. You have a code list for series in the SDG data structure definition. You have a code list for education level and a code list for reference area. So what's a code list? Name, value, pairs, right? So you have a code and you have a description in the natural, name and description in the natural language. What's important is, as you can see in the education level, in the code list for the education level, with the same code, you can associate names and descriptions in several languages. What's important to remember here is that this is completely abstracted in the data set. When you transmit a data set, you don't transmit the names, you only transmit the codes. The codes is what's important. So when you do receive the data set, you can basically expand or process it into any language. So, and these are the 2 primary functions that a code list has. One, language independence, and the other, controlled vocabulary. You can associate a code with a multiple language, and this gives you, this simplifies the processing of your data and visualizations, because you have this, you can associate the same code with multiple languages. You also define a valid range for the codes. When you enumerate your codes in a code list, if you try to transmit a code which is not part of the code list, that message is invalid. And this is part of what of the value added that Sdmx brings, the structural validation. If you did not have, I mean, you would still need your validation either way, and all statistical systems, or at least almost all, and definitely all well-designed ones, have some kind of a validation. Sdmx enables you to validate your message before you even send it. Code list structural validation includes checking that all the codes that you're transmitting are valid in accordance with the code lists. And when you have data exchange, that means you need to agree on a data structure, including concepts and code lists. And when you exchange the data, the code list must be harmonized among all data providers that participate in exchange. Now, not all concepts are associated with a code list. Some of the concepts are free text. That is, when you transmit them, you can include any text. So things like footnotes or comments, which are typically free text. This is how they are represented in Sdmx. However, you can also have a concept and specify a format for this concept. So for example, the US postal code or zip code has 5 digits, and you can put that into your data structure. Or you have a last update, date of last update of the observation, for example, that can be represented as a date time value. So in Sdmx, dimensions must always be either, dimensions must always either have a code list or have their format specified. You cannot have free text concepts as dimensions. Repeat. A dimension must have either a code list attached or a format specified. You cannot have free text concepts as dimensions. This is something which is very important to remember. Attributes can have a code list, can have a formatted, attached, or can be free text. On concepts, there are no, on attributes, there are no restrictions on their representation. You just need to specify some representation, but that can be code list, format, or free text. Something which I would like to say is that when people create, especially like participants of the training, when they create a data structure definition, they very often specify dimensions as formatted values. In reality, this is not a good practice, and in almost all data structure definitions, dimensions are always coded. They always have a code list. Why? I mean, think about the US Postal Code. You can get a code list of zip codes from the US Postal Service, or you can simply say 5-digit code. The thing is that a code list gives you a more robust validation. If you specify that the format for postal code is 5 digits, then 00000 is, strictly speaking, a valid value. 55555 is a valid value. You don't know whether it's valid or invalid until you look at, right? Whereas if you specify a code list for the postal code, then it's not enough for that code to be a 5-digit value to be valid. It also needs to match a list of valid codes. So whenever possible, a code list should be used instead of a formatted value. It's not always possible, But if you can use a code list, then do use a code list. That's the rule of thumb. And that applies to all dimensions except time period. For the time period, formatted value is used. It's expected to be in the datetime format. All right, so let's have a look at our data model again and see how we what we have here. We still have three dimensions: indicator, reference area, time period. We have one attribute unit multiplier, and we have the primary measure, observation value. Our attribute unit multiplier is attached to the time series. And we decided that for the indicator, we have a code list. For reference area, we have a code list. Our time period is a formatted value. And unit multiplier, although it's an attribute, is also has a code list attached. And finally, our observation value is a floating point number. So we have cross-domain concepts developed and published by the Statistical Working Group, and we also have cross-domain code lists. The Statistical Working Group develops and publishes cross-domain code lists. And when you have an existing classification for a cross-domain code list, and that classification is used. When you don't have an existing classification, then the codes are developed by the Statistical Working Group. Whenever you can use cross-domain code lists, please use those cross-domain code lists. If you have additional codes, okay, fine, you can instead those cross-domain code lists. But whenever possible, please use them. Why? Again, it improves interoperability. Because if everybody encodes sex, for example, in different ways, that makes it more difficult for our systems to talk to each other. Ultimately, it means more work for you and your users, because they will need to map your codes to the standard cross-domain codes. So some of the examples of cross-domain code lists you have here. You have a concept reference area, and you have a corresponding cross-domain code list, CL_area. You have a concept sex and a corresponding cross-domain code list, CL_sex. You have unit multiplier, and CL unit mult is the cross-domain code list. In addition to the full code list, you also have generic codes which are used for, which are recommended for use in all code lists as appropriate. So for example, many code lists, if not most, have a value total. And for that, the standard code is _T. It's recommended to use the codes. It improves interoperability, it makes it easier for your users to interpret and process your data. _Z means not applicable, also widely used code. _U unknown, and so on and so forth. So let's have a look at our data model, and let's have a look at the code list appropriate for our data model. So we created a code list for indicator. At this time, it only has one code, POP, which stands for total mid-year population. We have a code list CL area, which we imported from the global registry. So it has cross-domain codes for the various countries. And we have CL unit multiplier, which we also imported for the global registry. A quick note here, quick comment. What you see on the CL unit mult, this is a cross-domain code list. In Sdmx, it is, by convention, unit multiplier is expressed as a power of 10. So if your data doesn't have a multiplier, if it's expressed in units, then you will use code 0, because 10 in the power of 0 is 1. If you have your data in thousands, then you will use the code 3, because 10 to the power of 3 is 1,000. That makes it very easy to transform the data from the source database. And why? And this is also why unit multiplier is so important in the first place, because if the data is in your database is already in, let's say, thousands or millions, you don't need to transform it. You don't need to transform the observation value when you transmit it. All you need to do is assign the unit multiplier an appropriate code when you transmit your data set. And now we have the next quiz, representation. So I'm giving it to Luca. Please have a look at the data set and determine what is the best representations for some of the concepts. Not all of the concepts, just because that would be too long, just some of the concepts. So Luca, back to you.
Okay, so I will share my screen again so you can see the next question as anticipated by Abdullah. Once again, in order to connect, it's always the same procedure. You go on www.menti.com and use the same code that you used before that you see on the top of your screen, 71750241. We'll give a couple of seconds for everyone to connect. Okay, I see the number is hovering around 65. It seems quite stable. I think we can start. So, and if you want to join later, you can join at any time, and the code is always on the screen. Let's go to the question. What is the best representation for some of the concepts in these data sets? And you see the data set, which is the same one as before. But you also see for each answer, there is, for each concept, a proposed representation. So the way you should interpret the answers is, for example, for the first one, source is represented as a code list, sex as a code list, time period as a code list. And you only have 1.5 minutes remaining to answer. So I'll leave you to think about it a bit. Okay, we have 30 answers so far, still around 45 seconds remaining. I think, Abdullah, here the answer is a bit more clear-cut. There is a bit less space for interpretation than for previous quizzes, I would say. All right, still 10 seconds. If you are undecided, just put something in. 3, 2, 1. Let's see. Very nice. Very well done. We have a majority, outright majority of right answers.
Excellent. Yes, we have a majority now. So if you look at these options, okay, the two kind of red herrings, obvious ones, are where sex is represented by a 6-character string. There's absolutely no reason to represent sex as a 6-character string because sexes can be easily enumerated. And if they can be enumerated, then they should receive a code. So it should be a code list. So we have two, the first one and the second one. And there are two differences. In one, code list is sex, and code list is text, and in the other, think it's been a long day. In one case, source is represented by a code list, and in the other by free text. Which one is better? I think in this case, you have to make again, you need to make an assumption. If you can enumerate sources, then it's better to be a code list. If you cannot enumerate sources, then it's better. Then it better be a free text. And in this case, you have to make an assumption which one is better. Typically, source is in this case, in the case of the international data set, source is typically free text. It can be different when you're creating a data set at your national level, because at the national level, it should be easy for you to enumerate your data sources. And in that case, you can create data source as a code list. But in this case, looking at it, probably free text is more appropriate for concept source. And finally, time period. In one case, it's a code list. In the other, it's a date. Well, we spoke about this. Time period should be represented as conventionally represented as a date in Sdmx. And I don't think that representation as a code list is even supported. Okay, thanks. I think we're done, and I think we're getting excellent results, or they are quite improving quite visibly. Okay, 1 second. Where were we? Yes. Basics. Let me find where we were here. All right. And so let's have a look at our the data structure definition that we used in the in this presentation. Again, we have 5 concepts, and we determined that for the indicator, the appropriate representation is a code list. For reference area, also a code list. For time period, it's a date, in this case 4-digit year. Unit multiplier is an attribute attached to the time series represented by a code list, and the observation value is a number. What is interesting to note here is that if you look at the top of this slide, you will have 3 boxes there. You have 3 boxes there: concept scheme, DSD, and code lists. And these boxes, they represent so-called Sdmx artifacts as they're defined in the Sdmx information model. So strictly speaking, a DSD, an Sdmx DSD, does not have concepts and codes in it. Instead, it references a concept scheme, which is where the concepts are defined. And it also references code lists where the representation is defined. So in other words, you create a concept scheme, you create code lists to represent the concepts in the concept scheme, and then you create a DSD, which, what does it do? It assigns roles to it says which concepts it uses. So it takes concepts from the concept scheme, and for each concept, it specifies its role, dimension, attribute, primary measure, and its representation. Code list, or formatted value, or free text. And for the attributes, it also specifies the attachment, where the attribute is attached. They are maintained independently. We'll talk about that at the end of the presentation. And concept scheme and code lists are used by reference. All right. We are running behind the time, so let's quickly talk about the importance of the data model. We talked about the importance of correctly determining the role of the concepts. We saw how this can lead to errors. But the issue is that flows in a data structure definition, they can have significant impact on data exchange. You may have missing concepts, you may have concepts with an incorrect role assigned, you end up with an unoptimized model. Most of the time, that doesn't prevent you, I mean, the flows, they don't prevent you from exchanging the data, they just make it more difficult to use and maintain the data structure definition. And what is important to note here is that if you're familiar with the relational database design, you know that there is such a thing as a third normal form. You create a database, relational database, you ensure that the database is in the third normal form. But this is not the case for the data structure definition. There is no such thing as a third normal form. So whereas in the database design, you have rules, in the DSD design, you have considerations. And why are they considerations and rules? It's because when you design a DSD, you don't design it just for yourself. You are designing it for many parties by definition, for your users, for your data exchange parties, and for others. And this is why to achieve purity is very, in a data structure definition, can be quite difficult. When you design a DSD, you are driven more by pragmatism than by strict rules, which is why instead of rules, you have considerations. So I will not go into the considerations in detail. I strongly encourage you to use the guidelines for the design of Sdmx data structure definitions, which is published at the sdmx.org website. But the design considerations includes this. Parsimony. Parsimony means that you don't have redundant dimensions. You don't have extra dimensions that are not used, and attributes are attached at the highest possible level. In this case, it means that you would need to use groups for your attributes. And because if you attach observations only at the observation, if you attach attributes only at the observation or time series level, then that may not always be the most efficient. If you attach it to groups, that may be a lot more efficient. However, as I said, there is poor support for groups in SDMX, in current SDMX tools. We can expect it to improve in SDMX 3.0. Simplicity, that means you use mixed dimensions to minimize their number, right? So that perennial discussion of indicator and unit of measure, you may include a unit of measure in the indicator, right? In the case of GDP, I mean, for example, the national accounts data structure definition has separate concepts for STO, or the equivalent of an indicator, and unit of measure. So you have code GDP, let's say indicator GDP, and then you have units of measure currency and GDP and per capita. So this way you can transmit the same indicator is transmitted as, you know, the gross number or the per capita number using the unit of measure as a dimension. If you eliminate unit of measure, then you would have separate indicators. One is GDP and the other is GDP per capita. Which approach is better? I won't go into it now because again, it's I think that there will be further discussions subsequently. But I will say that in the case if you have, arguably, if you have unit of measure embedded in the indicator concept, then you have a mixed concept, right? Now, mixed dimensions, they are used to minimize the number of dimensions. They can help you avoid invalid combinations of key values. As I mentioned before, you won't have a situation where you have indicator surface area and sex male. And this is the opposite of purity, where each concept has its own, each characteristics of the data has its own concept. But again, if you're if you use too many mixed concepts, and if your DSD is simple, then you can end up with very large code lists, which are very difficult to maintain. Unambiguousness means that data must retain meaning outside its usual concept. For example, you publish your national accounts data. Do you publish your country with it? Do you publish your country code with it? Right? Very often countries publish their national accounts data without a country code. Why? It's because the assumption is made that the country code is your own. You publish, you are a national statistical office, you publish your national accounts data, you know that the country is your own country. Yes, well, yeah, when it's on your website, it's obvious, but once it's taken out of your website, it's no longer obvious, which is why you need to be careful about that. Density, it's very important, because what density means is that if your DSD is dense, then you have data for most combinations of your dimensions. So, for example, if your DSD does allow for indicator, surface area, and sex male, that means that you have a sparse DSD, because this particular combination, surface area and sex, they are not compatible with each other, right? It's an invalid combination. And that means that your DSD is sparse, right? So density is something that you need to look for. Maintaining the density at manageable levels for global data structures can be very, very difficult, because the global structures, they are extensive, they often describe very heterogeneous data. And then you have to make compromises, and many of the global structures are sparse. Orthogonality means that the value of concepts should be independent of each other, and that helps avoid ambiguity. But again, you have a simple model, and you may end up with difficult maintenance because you will end up with very large code lists. You can have a pure model where each characteristic has its own concept, and then that reduces the density because you'll end up with a lot of invalid combinations of dimensions. And if you try to split the pure model into multiple DSDs to improve density, then you can end up with dozens of data structure definitions, which makes it more difficult for you and for the user to map and consume the data respectively. So data set. What's a data set? We have mentioned this term before, but as David pointed out, we have not formally defined it. So data set is an organized collection of data defined by a data structure definition. And the key word here is A. A data set, an Sdmx data set, is a set of data which is structured in conformance with one and only one data structure definition. You cannot mix data from different data structure definitions in the same data set. So this is something to keep in mind. If you have a data set, then there's always one and only one DSD that was used to create it. And now that we have talked, we have also mentioned time series a number of times. So let's move on to the time series. What is a time series? And I have to say that this is something which I myself found very confusing when I started studying Sdmx. And once I had that straightened out in my mind, the rest was much easier. So time series is a set of observations of a particular variable which is taken at different points in time. GDP, for example. If we take GDP of the United States for 2000, 2001, 2002, 2003, and so on, taken together, this forms a time series. What's important to understand here is that there is no breakdown within the time series. I repeat, there is no breakdown within the time series. The only breakdown there is the time. And that means that if you take observations, different observations in the same time series, the only difference they have in terms of dimension is the time dimension. All the other dimensions are identical. Observation level attributes, however, they can and do differ across observations of the same time series. All right, so let's have a look at this slide. So this is an excerpt from the Millennium Development Goals database. We have two indicators: proportion of population living below $1 a day, and poverty gap ratio. We have two countries, Rwanda and three countries: Rwanda, state of Palestine, and Thailand. All right. So how many time series do we have here? You can think about it's sort of a quiz, except that it's not in Mentimeter. So you can think about this for a second or two. Think what the correct answer is. And let's count how many. Now let's count how many time series you have. 1, 2, 3, 4, 5, 6. And how can we prove that this is a time series? Is because if you look at these observations, you will see that their dimensions are the same except the time. So let's look at the top row. The indicator here, the series rather, it's the population living below $1 a day percentage, and the reference area is Rwanda. So if you look at these observations, at the three observations in this time series, then you will see that it has the same series, the same reference area, the time is different. Therefore, these three observations belong to the same time series. If there was a dimension that was different between these three observations, then that would not be a time series, then that would be sort of a mix of time series. If you have any questions, please put them into chat and we'll try and answer them shortly. In Sdmx, almost always data is represented as time series. However, a nine time series is also supported, or cross-sectional data. I mean, it used to be called cross-sectional in Sdmx 2.0, but in Sdmx 2.1, it's just called non-time series data. What it means is that instead of transpose a series again using the time dimension, it is transposed using another dimension or group of dimensions, right? And this makes sense for a data set that belongs to another, for the data structure that describes a single census or say survey, because in this case the time is fixed and you can transpose the data using another dimension. In Sdmx 2.1, 2.0, you had to sort of define it. In 2.1, you can change it dynamically. But non-time series representation is used less frequently than time series. Now the keys. This is important. What is a key in general? A key is a combination of concepts that let you identify one or more observations. Let's put it this way. So series key uniquely identifies a series, that is a set of observations. And if it's a time series, then by definition, the series key consists of all dimensions except the time dimension. So if we go back again, if you go back and look at this example, if you look at the top row, once again, the dimension values are for this top row, they're fixed for all dimensions except the time dimension. So in this case, our series key is what? It's indicator and reference area. That in this particular data set, that gives us the series key. And that series key identifies 1, 2, 3 observations. if we look at the top row. Okay, so this is important to remember. You can also define groups as said before, and you can also define a group key, which is basically, it's group key is essentially a partial key, and a group key includes fewer dimensions than what's available in the DSD. So then you can identify several times groups of series or groups of time series. All right, I think I'll pause now and take questions very briefly.
Yeah, Abdullah, I can't see any questions coming in.
Okay, good. Yeah, David. Okay, fine. You can think about your questions and you can ask them, and we'll get around to it after the quiz. Back to Luca for the next quiz. Here, just before we start, here we ask you to identify the number of time series in the data set. It's not a very easy question. You have to look very carefully. And just a hint, in this particular case, we're talking about Sdmx time series. So they may include one or more observations, right? And remember, to be able to identify the dimensions, sorry, to be able to identify the number of time series, you need to know your dimensions. And if you recall, your dimensions are frequency, indicator, reference area, sex, and time period. Back to you, Luca.
Okay, thank you, Abdullah. I'll share my screen again with the question. Same as before. If you have disconnected in the meanwhile, you can reconnect by going to www.menti.com and inserting the code 71750241. I see most of the colleagues who participated in the previous quiz are still connected. We'll give a few seconds for others to reconnect. Once again, you can connect at any time in the middle of the question and you'll be able to answer. Number of people participating seems to be stable, so we'll start. So you're working once again with the same data set as before, and as Abdullah mentioned, you need to identify the number of time series that are present. And for this, as Abdullah mentioned, you have 4 options: 9, 2, 4, and 6. And for this, it is important to know what are the dimensions. And I remind you that the dimensions here are frequency, reference area, that means country, sex, the time period, and the indicator. Those are your 5 dimensions. You need to identify how many time series you have. And I think this is another one where there is a very clear-cut answer. It's either right or wrong. There's little room for interpretation, I would say. Okay, about 15 seconds left. Time to make a decision. There should be about 10 of you who still have not made a decision. You have 10 seconds. 3, 2, 1. Let's see. Quite good. quite good.
Excellent.
Not quite an absolute majority, but a strong plurality. Very nice. Abdullah.
Yeah, thanks very much, Luca. Can you give the control back to me?
Of course, it's all yours.
Thank you. And let me share the data set once again. This was not an easy question. Very difficult, actually. And come to think of it, it might have taken me more than 2 minutes to figure out the answer. But anyway, now what do we need to remember here? These are our dimensions: indicator, reference area, sex, time period, right? And frequency. Well, here we have the same frequency and the same indicator for all the observations, so kind of they're out of the equation. Now, let's have a look at these first two observations. Indicator, share of temporary employees by sex for both of them. Reference area, Albania for both of them. Sex, total for both of them. And frequency, annual for both of them. The first one has time period 2010. The second one has time period 2011. What that means is that for these two observations, every dimension is the same except time. And that means that these two observations belong to the same time series. This is our first time series. Third and fourth row. Indicator, share of temporary employees. Frequency, annual. Reference area, Albania. Sex, female. Again, everything else is the same except the time period. Therefore, these two, again, one time series. Same thing here. Everything is the same. Indicator, reference area, sex, frequency. Only the time period is different. This is our third time series. 1, 2, 3. 3 time series so far. If you look at these ones, you will see that these have different dimensions in terms of sex. The first one is for sex total, second one female, third one male. And that means that each of these observations belong to a different time series, which is why, I mean, normally when you talk about time series, you talk about several observations. But in Sdmx, if you only have one observation and a time series representation, then you would have a time series consisting of one observation, which is why I said that an observation can consist of one or more, a time series can consist of one or more observations. Therefore, how many we have? 1, 2, 3, 4, 5, 6. And now I'm still expecting questions, but I don't see any new ones. But if you do have questions, we have very little time left, but please do ask your questions in the Q&A box. All right, I don't see any new questions. Once again, you have questions, put them into the Q&A box, and then we'll answer them at the end of this session. All right, so let me continue the presentation. We still have about 15 slides and about 15 minutes, so we'll have to go very quickly. David, can you see the presentation?
Yes, I can, yeah.
Okay, fine. So, what kinds of metadata do we have? Sdmx defines structural metadata and reference metadata, and it's not just in Sdmx. So your structural metadata, these are your identifiers and descriptors. Data structure, definition, concept, scheme, code, this is all structural metadata, and this is what we have talked about so far. Reference metadata describes contents and quality of data. Indicator definition, quality assurance system, comments and limitations. This information is reference metadata. In SDMX, reference metadata can be stored or exchanged separately from what it describes, which actually was seen as a strength originally, but now is also seen as something that can be quite difficult to work with. Reference metadata can be indexed, can be searched, and reported according to a defined structure. Just as you define data structure in, data structure definition to describe your data sets, you define metadata structure definitions to define your metadata sets. And an MSD defines the type of the object, the components, and the concepts used to express metadata. So let's see how it works in practice. And again, before I go on, reference metadata in SDMX 2.1 is extremely powerful, also quite complex to use. In SDMX 2.1, as well as in SDMX 3.0, you can define metadata which is directly linked to a data, such as a DSD, or that refers to a higher level object. But in this case, let's have a look at the MSD and metadata set, how it works. So in this case, we define, in our metadata structure definition, we define the target, that is where our metadata is attached. And in this case, we say that it's attached to a data structure definition, right? And the identifier is a partial key. And you might say that in this case, series and reference area is basically, you might say that logically it's a group. We also define the actual metadata concepts, or so-called metadata attributes, which define the content, the payload, what you transmit in your metadata set. So when you have an MST like this, you create a metadata set by providing the target. In this case, the target is indicator series, birth attended by skilled health personnel, and the reference area, in this case, Cambodia. And then you also specify the concept, the indicator definition and method of computation. So this way, with this setup, you can say that for the country, for reference area Cambodia, an indicator birth attended by skilled health personnel, the definition of this indicator refers to the proportion of deliveries that were attended by skilled health personnel, including physicians, medical assistants, midwives, and nurses, but excluding traditional birth attendants. This is your indicator definition. And the method of computation is the number of women of aged 15 to 49 with a live birth attended by skilled health personnel during delivery is expressed as a percentage of women aged 15-49 with a live birth in the same period. Okay. In SDMX 3.0, reference metadata was redesigned following extensive discussions. And the main impetus for those was to simplify the implementation, the discovery, and use of reference metadata. The issue is that unlike data exchange, reference metadata exchange in SDMX has not taken off on anything like the same scale. And why did it not take off? It's because there are still very few tools available in support of reference metadata exchange. And why are there so few tools? It's because the reference metadata exchange is so complex. So in SDMX 3.0, there was a push to simplify that, and it was greatly simplified. So now you can you can describe reference metadata concepts as part of the data structure definition, and you can transmit reference metadata as part of a data set. Right? However, you can also, if you choose, you can also submit your reference metadata in a separate message. You still have metadata structure definitions and metadata sets and metadata flows for higher level metadata. For example, if you have reference metadata on statistical legislation, it doesn't make sense to attach it to a particular statistical data set because it typically applies to the entire country or sometimes maybe even a group of countries or a union, right? So it doesn't make sense to attach it specifically to a data set on, say, national accounts or demography. It applies to all of them. So for higher level metadata like this, you still have metadata structure definitions, metadata sets, metadata flows. However, for metadata, for example, on indicated definition, quality aspects, method of computation, which we saw before, those are closely tied to the data, and those you can define as part of the DSD and transmit as part of a data set. All right. Data flow and metadata flow. What is a data flow? If you are familiar with, a data flow can be thought of as a transmission or communication channel. In practical terms, it can also be thought of as a view on a data structure definition. So if your data structure definition, if your DSD defines a universe of data or a hypercube, then you can compartmentalize that hypercube. You can slice it into parts and you can assign data flows to each of the different parts. Why is it done? To basically make it easier to discover the data, to query for the data, to transmit and receive the data. So with a data flow, you can attach additional constraints. So for example, I think it's been too long. If you have, let's say, SDG data exchange, and you have a DSD for SDG indicators, you can define, if you wish, you can define a data flow for each of the 17 goals. And then that makes it easier for the user because when they know that they need all data for goal 2, for example, they can just query the data flow for goal 2 and get all the data from there. Alternatively, if you have a data flow that covers all the 17 goals, they would have to know which indicators they need to retrieve from there that they need. So it's obviously easier to query, simply query the data flow for the goal. As described, we can also attach categories to the data flow, and categories are simply labels or tags to simplify the discoveries. So for the SDG, we can attach development indicators. For national accounts, we can attach macroeconomic statistics. These categories can be used to browse your data and simplify the discovery. So in a similar way, metadata flow defines a view on a metadata structure definition. Very important, content constraints. Content constraints can be used to define combinations of codes that are allowed, typically. They can also be used to describe combination of codes which are not allowed. So for example, if you have an indicator series, proportion of women in commune councils, then the only valid sex for that indicator series is female. And you can have a content constraint that describes that. Therefore, the constraints define a more granular validation rules. They have more granular rules than a simple validation of codes. And you can attach constraints to a DSD provision agreement and so on. But typically, the content constraints are attached to a data flow. Category scheme, category and categorization. We have talked about that. And they're used to tag the data, to attach labels to the data to simplify discovery. And category scheme is simply a list of categories, whereas categorization links category and the object to which it is attached. Okay, so I have indications that we need to wrap up. So we only have very, very few, very little time left. I'll skip this one. It's, this is how you can attach categories to the categorization. So we talked about SDMX messages briefly. Again, any SDMX related information is transmitted in messages. So if you have a data set, it's transmitted as an SDM, it's packaged and transmitted as an SDMX message. If you need to transmit a DSD, it's also packaged in an SDMX message, and so on. So this is basically just to know that an SDMX message is a unit of SDMX information. SDMX artifacts. When you hear concept scheme, DSD, code list, almost always it's these are all SDMX artifacts, and almost always when we say about SDMX artifact, it means maintainable artifact. So for example, code is not a maintainable artifact. It's usually not referred to as an artifact. Concept is not an artifact. Concept scheme is an artifact, and the code list is an artifact. And here you have some examples of the specific examples of the artifacts. What is very important here is that identification of an SDMX artifact consists of 3 fields: the ID, maintenance agency, and version. So in this case, if you look at the top row, you can see that the data structure definition for national accounts main aggregates has ID NA_main, maintenance agency ESTAT, which stands for Eurostat. Version, in this case, is version 111. So if you look at the first 2 rows, you will see that it's 2 versions of the same artifact. So basically, there are 2 separate SDMX artifacts, right? So when you publish your artifacts, if you assign your own agency, maintenance agency, when you create your artifact, then even if somebody else has an artifact with the same ID, they will not clash because their maintenance agency will be different. It's also very important that if you try to modify somebody else's artifacts, for example, if you take a code list from the global registry and add codes to it, it's extremely important that you change the maintenance agency to your own agency. This way, you maintain versioning correctly. And in SDMX in SDMX through 2.1, simple versioning has been used, but in SDMX 3.0, semantic versioning has been introduced, and it's more complex and more flexible. It's a more complex versioning scheme that should make it much easier to use SDMX artifacts. Let me put it this way, it's more flexible. And we have the last quiz and the last slide. I don't think we have the time left for that quiz. But basically the objective was to ask you which of the following are SDMX artifacts: DSD, code, concept, or a database. And the correct answer of this is DSD. DSD is the only SDMX artifact there was. DSD, concept scheme, code list, content constraint, category scheme, they are all SDMX artifacts, whereas maintainable SDMX artifacts, whereas code, category, concept, or they are not maintainable artifacts. So thank you, and thank you for your patience. I think that it can be very late where you are right now. So many thanks for your patience, and thank you for your attention. And this is the first time that we're running this presentation in this format. So we do apologize for any issues that we might have had. Thank you. And perhaps Inehi would like to say a few words, but basically we are done for today's session and we can wrap up.
By the way, Abdullah, just for you to know, as you were speaking about the quiz, I still started it because there were some people connected. But unsurprisingly, the results were very good.
So we got a huge majority, hopefully.
Yes, to end on a good note.
Okay, so thanks very much. Capacity building will continue tomorrow. And if you have taken the basic course, I think that you can find Tuesday, Wednesday, and Thursday quite interesting. If you have not, if this is the first time you've had a basic course, you will still find it all the more interesting. So please join us tomorrow at the same time. And now I think we can end this session. Thanks very much once again. And many thanks to Luca and David for their support.
Thank you, everyone.
Thank you, Abdullah. Thank you, everyone.
Thank you, everyone. Abdullah, thank you very much, everyone. See you tomorrow.
Okay. Thank you very much. See you tomorrow.
See you.